So what are chemical equations? Well, it's really just a nomenclature system. It's just a way for us to symbolically represent what's going on. So we have chemical symbols and chemical formulas before we can get to chemical equations. Every element has a designated chemical symbol. They might have two letters, they might have one letter, but the first letter is always capitalized. If there is a second letter, it's always not capitalized. So capitalization matters. That's going to be an important feature of making sure you know how to capitalize properly your chemical symbols. Then I can put, for compounds or for diatomic molecules, I can put them into a chemical formula. So when they are bound together, we represent that they are bound together by using a chemical formula employing subscripts. Subscripts are little numbers below the line that tell us how many atoms of that type of element are bonded together. So if we look at this Ca parentheses ClO3 parentheses 2, we see that there are two subscripts in there, one after the O and one after the parentheses. So each of those we see several elements in here. The first element we see is calcium, Ca. I know that the A is part of the symbol because it's the lowercase, so I know that C and the A is the first element. And then in parentheses, I see a Cl. Again, that would be chlorine. And then I see O for oxygen. So the 3 means that within the grouping in the parentheses, I have 3 oxygen atoms bonded to 1 chlorine atom. And then the 2 outside the parentheses means that there are 2 groupings of 1 chlorine atom with 3 oxygen atoms, for a total of 2 chlorine atoms and 2 times 3 or 6 oxygen atoms. So the representation of CaClO3 tells me that I have 1 calcium atom, 2 chlorine atoms, and 6 oxygen atoms. So we do want to be careful making sure we understand that the word subscript talks about the numbers that are below the line. In a minute we're going to talk about the coefficients, which we're going to employ in a chemical equation. So a chemical reaction or a chemical equation of a chemical reaction are going to be now a recipe for a chemical change in which we have chemical products that are being made from reactants. Each reactant is an individual substance. It might be an element, and it might be a molecular element, it might be a compound, and then it is reacting to form product or products, again, other elements or compounds. And so I have the representation of the substance with its own subscripts, but then I also have the proportion of this recipe, and the numbers in front of each substance indicate the quantity of those, how much I need, what is the proportion, and we're going to call those coefficients. So where the number is really makes a difference in these things. Also, we're going to put the reactants on the left side of the arrow because they are what's there at the beginning. We think like we're reading in English language where it goes from left to right. So left is the beginning, those are the reactants, and everything on the right side of the arrow is the products. Note that in every chemical reaction, something that's happening behind the scenes is that I have to break bonds and or make bonds. Something has to be happening to bonding. That's really the essence of the chemical reaction. And if I'm looking here, I can sort of see that I have iron atoms, so they're not bonded, and then I have O2, those are those molecular elements, so it's 2 oxygen atoms bonded together, and I'm going to have to break those bonds so that I can make the product. Now I'm going to recombine those individual oxygen atoms with the iron in a new ratio of 2 iron atoms to 3 oxygen atoms. That's going to be my product, and in order for this all to work out, I need to start with 4 iron atoms and react it with 3 oxygen molecules to make 2 Fe2O3 compounds. Also, you'll see that we use S, G, L, and you'll also see AQ for the states. So solid, liquid, gas. AQ means aqueous or mixed with water. So we will get more into chemical reactions much farther on in the course, although we're going to start with some balancing in a moment. So just to kind of get where we're at, let's practice circling each substance in these reactions and label it as either a reactant with an R or a product with a P. Then I want you to take apart each reactant or product and tell me what elements are in it and how many atoms of each type of element there are in that substance. And then I want you to box the coefficient of each substance, so I know that you can identify the coefficients.